Hello, my name is Emmanuel Riverosa, and I'm going to tell you about the Spectre vulnerability. It was discovered by Jan Horn from Google Project Zero and Paul Kocher. Hardware vendors were notified in June 2017, but it wasn't made public until January 2018. The reason there is a 6-month gap is because if the vulnerability is announced as soon as it has been found, then a malicious person could take advantage of the vulnerability before a solution has been found and tested. This does leave the possibility for attackers to take advantage of vulnerabilities during that time, instead of a company rolling out a fix as quickly as possible, as all companies roll out their software on the same day. But this has become the standard in computer security. Almost all computers since 1995 can be affected by Spectre, whether it is a desktop, laptop, or mobile device. All companies are also affected, including Intel, AMD, and ARM. Spectre was named after a technique implemented in hardware called speculative execution. So what is speculative execution or branch prediction? Modern processors can execute code without being certain that it is the correct path to take. First, the processor will save all the registers and memory before trying to take a branch. Then, it will try to predict the correct branch to take based on several factors, including previously taken paths like in a loop. If the guess is correct, it saved itself many clock cycles in the CPU pipeline. If it was wrong, then it starts over with the correct execution path and the previously saved registers and memory, as if it had waited to find the correct branch. An example of speculative execution is this loop. Without looking ahead, after the 10th or 20th iteration through the loop, you can safely assume that the flow of control will return to the top of the loop once again. This is branch prediction. Speculative execution is using that prediction to start calculating values before you're 100% sure that this is the branch that the code will take. If your prediction was wrong, like at the 100th iteration of this loop, then you simply discard the previously calculated values and continue working. An introduction to out-of-order execution. Out-of-order execution is used when a CPU detects that an instruction needs information that hasn't been computed yet. If this occurs, the CPU will move to the next couple of instructions to see if it can execute these instructions first, instead of waiting on the current instruction. The CPU keeps track of all instructions in the reorder buffer. The reorder buffer is a queue of the intended instructions, which means that the instructions are only committed in memory in the order that they were meant to be executed. This is a possible example of out-of-order execution. Since we know that matrix multiplication is a taxing operation and it will take a long time, and the addition needs the result of the addition to operate, while it waits for the multiplication to take place, the CPU can move on to the subtraction line because it can run without waiting for anything else to run before it. Okay, with all the prerequisites out of the way, we can now move on to the good stuff. The Spectre and Meltdown vulnerabilities. The basic steps are to locate a section of code that leaks data, then trick the computer into executing this section of code, and finally retrieve the information from the cache. This is a piece of code that can be used to trigger a Spectre vulnerability. It looks a bit funny because you're using an array value as the index of another array, but I'm sure you can imagine that array 1 is an array of numbers that aren't necessarily in ascending order, but you always want to read values in this order for array 2. Nevertheless, For the Spectre vulnerability, this is a simple loop that can illustrate how Spectre works. You first train the branch predictor that this loop will happen many times, and it can predict where in array 2 the value of y will be by making the first 100 values in array 1 to be sequential. Then you suddenly inject a value for x that will call an out-of-bounds value of array 1. This is the reason you need an array to hold the index values of array 2. Because of speculative execution, the next value of array 2 will still be looked up even though it was not the correct value to retrieve. The vulnerability is that this incorrectly taken value is spit out to cache because it wants to take the correct path as quickly as possible. Because computer instructions do not do any checking for the bounds of the array, you can essentially read any data you'd like in the file of the currently running process. If you have previously heard about Spectre, you've probably stumbled upon Meltdown as well, because they were released to the public on the same day. Meltdown is a specific vulnerability in the family of Spectre vulnerabilities that only affects Intel processors. They both exploit speculative execution, but while Spectre uses branch prediction, the Meltdown vulnerability exploits a weakness in Intel's implementation of out-of-order execution. Meltdown is similar to Spectre. First, you run a stream of data in the CPU that you know contains data you want to access in such a way that you know it will be executed out of order. Then, while the information is in the pipeline, you force the CPU to trap a signal. When an interrupt like Control-C in Linux or Control-Alt-Delete in Windows is sent to the CPU, the instructions that were being executed out of order are dumped into cache. This allows access to kernel memory, which includes passwords and other very private information. This is an example of what can be done with Meltdown. Although this is run on the local computer, this attack can also be taken place in the browser using JavaScript. Now that we know how Meltdown and Spectre work, you might be wondering how to protect yourself from such an attack. When the attack was first announced, the US Computer Emergency Response Team said the only solution was to replace all CPUs, and as you can imagine, this is not a realistic solution. The best way to protect yourself from such an attack is to keep all software, especially UEFI and your operating system, up to date. A less secure method, but also helpful, is to use something like an antivirus or firewall software. These types of software will prevent previously used malicious code to run on your computer. The reason Spectre was such a big deal is because it is a problem in the hardware, which is very difficult to fix in software. While companies like Microsoft have released patches that prevent such an attack, the first patch decreased processor performance by an average of about 15%, depending on the workloads tested. Security researchers are still finding Spectre exploits over 2 years after the initial release, as there was an exploit discovered in August 2019. So, ongoing operating system and other software updates is extremely important. This is the end of this lecture. If you'd like to learn more, I encourage you to read one of the articles written by Paul Kocher, who happens to be one of the initial discoverers of the vulnerability. The article is called Spectre Attacks Exploiting Speculative Execution and can be very technical, but it gives more detail, especially more quote examples of how the exploit can work in concrete. And this was the starting point for my research for this lecture. I really enjoyed making this lecture and found it interesting to dive deep into the subject of Spectre and Meltdown, and hope you enjoyed watching it. Thank you.